Okay, so you made it back. Today we're going to be talking about acceleration. So fun. So let's talk about what it is. Let's just throw the equation on there. Acceleration is going to be equal to delta V over t. Alright, so what we're talking about here is delta V. Whenever you see this guy, remember the delta means change in velocity. Now, velocity is going to be in meters per second, and T stands for time, just like you would expect. Time is going to be in seconds. Alright, so when we're talking about acceleration, we're going to take the change in velocity, dividing it by the time. Now the units for that, we're going to have meters per second divided by second. Alright, so this is meters per second, or as we're going to more often write, meters per second squared. Okay, now I know that's weird to think about right now, because what's a meter per second squared? Alright, so it's the change in meters per second for every second. Let's give you a different example, in units that you understand. Let's pretend you are sitting in your car. Your car looks great, by the way. You're in park, and then you put it in drive and you put your foot to the floor. Alright, you look at your speedometer, which also looks very interesting. So you're going to start at 0, and you notice that the needle is going to be going up. So it's going to go past 10 miles an hour, 20 miles an hour, 30 miles an hour. Alright, let's say that it takes 1 second to move each step of the way. Alright, so it takes 1 second to go from 0 to 10, 1 second to go from 10 to 20, 1 second to go from 20 to 30. So what this means is you're accelerating. What's your acceleration going to be? Well, using English units here, your acceleration is going to be 10 miles per hour per second. Okay? Now, the same thing happens in the metric world over here, but the hours and the seconds, there's a way to cancel those out. You know, to combine the like terms together, because it's the hours is in the denominator as well. But that's what acceleration is. So maybe this is a good one to think about when you're driving or watching someone drive, I don't know. But we're going to be using meters per second squared. Let's do some practice on this. We are going to be accelerating at 6 meters per second squared for 4 seconds from rest. What is your speed? Okay, so we are going to start at rest, so that means our velocity is 0. And then we are going to be accelerating for 4 seconds. And over here, we're starting to move at 6 meters per second. Alright, it's good to draw a picture to help you out. Now, let's write down our formula here. Acceleration is equal to delta V over t. Now, let's see. We know what our acceleration is. Our acceleration is the 6, so we're going to throw a 6 into there. We know what our time is. So our time is going to be 4 meters per second, and we have delta V up here. So solving for delta V, oh, I did it backwards, didn't I? So delta V is going to equal 4 times 6, which is 24. Now what's the units going to be? The unit's going to be meters per second, because it's a velocity. Now, this doesn't mean necessarily that you're going at 24, but your speed changed by 24. So we started at 0, and then we're going to add 24 to that. And so that means that our final speed is going to be 24 meters per second. Oh, this one's acceleration, so that should be a square. So this one's going to be our answer right there. Ta-da! Let's do another one. We are traveling at 45 meters per second and brake for 3 seconds, slowing to 30 meters per second. What's your acceleration? All right, you should pause the video and give this a shot. Let's see if you did all right. So I know that acceleration is equal to delta V over t. That's what we're going to be using here. Now, I'm looking for the acceleration, so I don't know what that is. Time, I know what the time is. Time's right there, so that's going to be 3 seconds in the denominator. Now, I'm traveling at 45, and I slow down to 30. So which one of those is going to go in my delta V? Neither one. I have to figure out what the change is. Now, remember, for science, you know, I'm saying science instead of physics because it's for chemistry too. So when you have a delta is always going to be your final minus your initial. This is for anything, even math too, I guess. But whenever they mean changing, they always mean final minus initial, every time. So your final speed is 30, and your initial speed is 45, which means your delta is going to be minus 15. Now this should make sense because you're dropping speed, right? You're going from 45 to 30, so it should be a negative number there. And remember, a negative number makes sense because this is a vector, right? Your velocity is a vector. It has a direction to it. The direction is in the negative direction this time. So because you're changing that way, right? To the negative way, to the left, if you want to think of it like that. So that means your acceleration is going to equal negative 5 meters per second squared. Now, you will notice that your acceleration is negative. It can be negative because it is also a vector. Because it also has a direction. You can be accelerating one way or the other way. In this case, because it's negative, this means you're decelerating. All right? Decelerating just means you're accelerating in the negative direction. Okay, so if you're driving forwards and you slam on the brakes, you're just accelerating backwards. Okay, if you're driving in reverse and you slam on the brakes, you're accelerating forwards. Right? If you drive backwards and hit the brakes, it's going to have the same feeling as if you're still and you punch it forward. It's going to have the same feeling because you're accelerating the same way. Right? So that's what we want to cover for this stuff. So as long as your velocity is changing, that's accelerating. All right? So you can be positive, negative, or side to side, but we're not going to do 2D motion quite yet. You're driving at 15 meters per second and then accelerate at 0.45 meters per second squared for 6 seconds. What's your velocity? Okay, you should be pausing the video now. Give it a shot. We'll be back to you in a second. All right, let's see how you did. So we're going to start off with our wonderful formula here. Acceleration is equal to delta V over t. All right, so we want to solve for velocity because that's what we do. Delta V is equal to AT. I know what the acceleration is. The acceleration is equal to 4.5 times 6. So that means 4.5 times 6 is 27. And that's going to be meters per second. So that's my delta V. But remember, I'm not going at 27 meters per second because I had a head start at 15. So I was at 15, and then my delta is going to be 27. So I'm just going to add the 27 to there, right? Because I went up by 27. So adding those two together, we get 42 meters per second, right? Because we were starting at 15. That's our initial. We went up by 27. We end at 42. That's our final velocity. All right, that's it for now. Tomorrow we get to have more fun with acceleration. We'll see you then. Make sure you like and subscribe.